Friends, we are going to discuss now the next part of the physics 1, unit 1, elasticity, equivalence of the shear strain to the compression and the extension strains. That you have to see directly. We are not going in detail of this particular thing. We are just fond of, or say we want this particular MCQ questions. Okay, that's why here the shear strain is equal to two equal strains, an elongation strain and a compression strain at right angles to each other, each being equal to half the shear. Shear is equivalent to two equal strains, an elongation strain and compression strain. This is very much important as far as the MCQ is concerned. I am just going to highlight the MCQs. Okay, then now we have to see relation between the elastic constant, that Young's modulus, bulk modulus and Poisson's ratio, all these things. Here y is equal to 3k in bracket 1 minus 2 sigma for the isotropic homogeneous medium. Okay, this is valid only for the isotropic homogeneous medium. Here that is a proof is there, but we are not going in detail of such a proof. Then another y is equal to 2 eta 1 plus sigma. This is again the another relation is there. Okay, that you have to remember. We are not going in detail of such a derivations. Then here one more c, you can see 9 by y is equal to 1 upon k. Another relation is that 9 upon y is equal to 1 plus k plus 3 by eta, and sigma is equal to 3k minus 2 eta divided by 6k sigma k minus 2 eta. That two derivations, these are the limiting values of the Poisson's ratios are here given. Y is equal to 3k in 1 minus 2 sigma, y is equal to eta in bracket 1 plus sigma, 3k minus in bracket 1 minus 2 sigma is equal to 2 eta in bracket 1 plus sigma, where k and eta are both are the positive. Okay, these are this derivation you have to remember. Here the thing is that you have to see this. What is the torsional constant? C is equal to pi eta r raised to 4 divided by twice L. The twisting couple or say torque required to twist the cylinder rod at a free end is given by tau is equal to c into theta, where c is nothing but a torsional constant that you have to remember. Okay, that may come for the MCQ purpose. Only this MCQ you have to prepare. Here you can see the detailed derivation is there for this, but we are not going in detail of this. Modular rigidity, I said stress upon strain, stress upon shear strain, that is the modulus of the rigidity that you have to remember. Okay, very simple part it is again. Then the numerical is there based on these formulas. Okay, for silver y is equal to 7.3 into 10 raised to 10 Newton per meter, and k is that value. Find the Poisson's ratio, that sigma you have to calculate. Okay, very simple. All the values are given, that just you have to substitute in the formula and then you will get that particular thing. Here the some numericals are given. Dimension of the Poisson's ratios are dot 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 dot. Okay, 4 different options are there. Poisson's ratio is the dimensionless, as you know. Okay, then the homogeneous isotropic material Poisson's ratio sigma is, that range is given. For isotropic material, Poisson's ratio sigma is in between this particular limit, that is a -1 less than sigma greater than 0.1, that is a 0.5. Then which of the following material is highly elastic? Rubber, steel, plastic. Steel will be the highly elastic, that you have to remember. It can bend in any that particular thing. Within elastic limit, the stress is directly proportional to the strain. Okay, modulus of rigidity is shown by solid only, that you have to remember. These are the certain MCQs are there in the derivation. You can see here psi must be lie between the -1 and a 0.5 or say plus half for the homogeneous isotropic material, that is given over here. Huh? If you're not getting anything, you can ask to me, but whatever I am saying, whatever I am highlighting, please go through this part. It is very much important. Here the derivation of this particular thing is given for this relation between the y is equal to 3k in bracket 1 minus 2 sigma. Young's modulus we know, longitudinal stress upon longitudinal strain. Then you can modify this thing. Then you will get a formula that elongation under compression you can calculate. Then finally you can apply it for the all the axis. First of all, if you are calculated for the x-axis, then you can calculate for the y and z axis similarly. Then whatever the increase in the volume of the cube will be there, elongated side of the cube will be there, that is given volume strain, then bulk modulus k. You can substitute all this thing, then you will get this particular derivation y is equal to 3k in bracket 1 minus 2 sigma. Okay, MCQ purpose of you, what will be there? I said for the homogeneous isotropic material, that y give the that particular what we can say Poisson's ratio. Okay, at that time you have to write the y is equal to 3k in bracket 1 minus 2 sigma. Then another derivation is there for that purpose, is that nothing but the y is equal to 2 eta in bracket 1 plus sigma. Okay, please go through this. If you are not getting, you can easily ask freely ask to me on the WhatsApp or say any group. Okay, thank you.